You're tuned into our webinar with Opsilog, Beyond Monitoring, How Data Science Fuels Smarter Offshore Operations. Our guest speaker is Opsilog's data scientist, Samanth Chinta, who will be leading the presentation today. If you have any questions for him, do type them in the Q&A section and we'll get them answered for you. And here's Carl Jeffrey, founding editor of Digital Ship, to explain more. Take it away, Carl.
So our topic today is how we can use data science to find ways to make efficiencies in offshore operations by helping improve our data quality. Because if we want to find better ways to operate vessels, we need to have data we can rely on. For example, to know what the ship was doing at every point during the day, its location, its speed, and its fuel consumption. Most of your data is going to be correct, but a small incorrect piece of data will mess up the analysis. And basic data validation checks aren't good enough because they can often miss data inaccuracies. For example, if a flowmeter needs maintenance and gives a slightly incorrect fuel consumption reading, or crew don't report exactly when the vessel finishes one task and starts the next one, or an AIS transponder transmits the wrong GPS data for a short period of time. Data science and AI can help identify where data is incorrect because it doesn't fit a pattern. It can flag up that data should be checked or maybe suggest what the correct data should be. We're going to have a talk today from Samanth Chinta, data scientist with French marine offshore software as a service company Opsilog. He's joining us today from Marseille in France. Samanth has worked as a data scientist for Airbus helicopters, and he lectures at Albert School, Marseille. That's a data-driven business school on linear models in econometrics. So we'll have a talk of about 25 minutes, then we'll take your questions. And I'd like to invite Samanth to start his talk.
Thank you very much, Carl, for the introduction and the invitation also. So I will just share my screen. Here we go. Okay. So we good?
Yep.
Okay, thank you very much. So indeed, today we'll be talking about how you can turn your data into business value by applying data science methodologies, more precisely in the offshore and maritime industry. So just to give you a quick introduction about myself. So indeed, I've been working in different data-related positions for 10 years and in different fields. So in retail, logistics, aeronautics, and now the offshore industry. So I've been working at Opsilog for a year and a half. And just to give you some context regarding Opsilog, so basically, what we do is we support our clients, so mainly ship owners and charterers, in improving both operational and fuel efficiency. And we do this by leveraging the data they report to us, as well as external sources like flowmeters for fuel consumption or AIS for vessel positioning. So far, most of the value we've delivered has come through analytics, so combined, of course, with our offshore expertise. But over time, we realized that there was even more potential locked in this data, and that's what led us to start implementing data science methodologies. So I'd like to share some insights on how you can extract more value by embedding data science into your operations. And I'll walk you through a few real-life examples from what we do on a daily basis at Opsilog. So regarding the agenda, so I will give you a quick introduction on what is data science globally. I will give you some definitions to make sure we know what we are talking about. Then I will give you some benefits that you can have from implementing such methodologies. Then we'll go through some use cases on which you could work on, at least at Opsilog we work on. And I will go through a concrete example of what we are deploying and implementing at Opsilog and how it improves the way we work with our clients and our performance and their performance. And we'll finish with some key takeaways. And hopefully at the end, you will have an idea of what data science is, if you can implement it, and on some if you have some ideas of some use cases you could work on. So To start, as you must know, the amount of data that we generate and collect keeps growing today. And of course, the offshore and maritime industry is no exception. But now the challenge is turning this data into value, basically. So in the offshore industry, one major opportunity lies in improving operational efficiency, which can directly contribute to reducing fuel consumption. And that's where data science can be a powerful tool, but only if it's implemented properly within your teams. So what is exactly data science? So in short, it's a multidisciplinary field that combines mathematics, statistics, and computer science. So the goal here is to build a model. So it might be different things. So a machine learning model, a deep learning model. It can also be generative AI model like LLM, like large language models. We talk a lot about this today. So these models take data as input, and they produce useful business output. So that output could be many things. So it can be a prediction, it can be a forecast, it can be any specific piece of insight according to the use case. But the key point that you have to keep in mind is that the model must solve a real business problem. So no matter how technically accurate or impressive the model is, if it doesn't meet a business need, then it won't be used, and that makes it all worthless. So that's why it's very important, and I think it's the most important thing. It's very important to view data science not as an end in itself, but more as a means to support your business objectives. So to succeed, you need strong collaboration between your teams or business teams, product teams, tech teams. I insist on this because in the past, a lot of data science projects in different companies, big or small companies, failed because of this lack of collaboration. So, and that's why, as data scientists, you not only need strong skills in math, statistics, and computer science, but also the ability to understand business challenges, and also the creativity to design solutions that actually address them. Okay, so here are some key improvements that you can gain by applying data science in your operation, always by addressing a business topic. So here we take the example of operational excellence in the offshore industry. So basically that's what we do at Opsilog. So first, it will help you improve your data quality. Why is that? Because this is very straightforward. To build an accurate model, you need clean and reliable data, which means you're naturally pushed to clean, structure, and qualify your data. And in turn, once the models are in place, they can help detect anomalies or enrich the data. We'll see just after. So that's why it creates a kind of a virtuous cycle, let's say. And that's actually what we see today at Opsilog. Thanks to this improved data quality, so we've been able to offer a much better performance monitoring for our clients. This is what we do on a daily basis. Why is that? Because, as I said, the insights now are based on validated and consistent data, which makes the monitoring more accurate for our clients. Another common issue you might have faced, I guess, is data overload. So you may have tons and tons of data, but no real tools to process or extract value from it, especially if you're still relying on Excel spreadsheet, for example, which I guess quickly becomes a bottleneck. So at Opsilog, we are implementing technologies like Apache Spark, for those who know, which allow us to process billions of data points from connected vessels, for example. So this is massive. And so for these technologies, the good news is that they are very easy to access today through cloud providers like AWS, GCP, Google Cloud Platform, or Azure, Microsoft Azure, where, for example, at Opsilog, we work on Azure. So there's no need to reinvent the wheel. The service is accessible. Of course, you need some computer science skills to use these services. Another very important thing is automation. So with data science, you can automate non-trivial but low-value tasks. I say non-trivial because for trivial tasks, of course, you don't need to implement data science. But this will free up a lot of time to your team, for your teams to focus on higher value activities. So this is very important, especially for ROI, for example. It's a win for everybody because on the one hand, you will gain a lot of time by automating the processes. And on the other side, your teams will work on much more interesting and value-added tasks. And finally, one last thing, through data science, we're able to improve the way we communicate to our clients through notification, which is very important because it's much easier for us to communicate with some clients. For example, if we detect some anomalies in terms of reporting data, we'll come to this just after, we can push a notification, they can correct the data and then send it back to us. So then we increase the data quality and then we start the loop again. So basically, these are some of the key benefits that you can get from applying data science methodologies within your business, and that's what we see to every day at Opsilog. Okay, so now that you have some ideas of how we can benefit from it, I would like to give you some examples of use cases that you can work on in your business. I will give you some examples. The list is not exhaustive, of course, but I hope it will give you some ideas of what you can implement on your side. We've splitted our use cases into two main categories. So the scoring use cases and the modeling use cases. So even though both categories use similar models under the hood, what really makes them different is how the output of the model is used in the process. So we'll start with the scoring use case, the scoring use cases. Here, the goal is to assess a data point, to evaluate, to qualify a data point, for example, to check the quality, its quality, or evaluate operational behavior. So this is very important to assess a data point, especially in the offshore industry, because, as I said, we are dealing with more and more data, lots of data, and often reported manually or coming from different sources, which increases the risk of having low quality data. So I'll start with the first use case, the reporting one. So as I said, at Opsilog, offshore vessels report their operational activities to us. And basically, we use this reported data to power monitoring dashboards to our clients. So that's why the accuracy of the data that they report is critical for us. And so that's why we developed a model that interprets vessel positions and infers operational activities. And then we will compare the output of the model with what is reported by the vessel. This will generate a score for each reported sequence, and that will help us detect anomalies and inconsistencies. And if something looks off, we can flag it and ask the vessel to correct the report before we integrate it. So this is the example I will deep dive into just after, so I won't give you more information on this. We can do this. So we do this for reporting data. We can also do this with third-party data sources like EFMS or electronic fuel systems for fuel consumption, for example, or AIS for vessel positions. Of course, here the goal is not to audit or rate our providers, but it's more to ensure the reliability of what we are integrating. Just to give you an idea of what happened in the past, we once saw a vessel who was operating in Africa. Seconds later, he was in Southeast Asia. Then he came back to Africa and made some back and forth. So obviously, something was wrong on the data. So basically, this models can help us catch those issues earlier in the process, so that we can detect them, correct them, and display corrected data. Another example can be scoring operational behavior. So again, here the goal is not to rate our clients, but more to give them some rooms for improvement by identifying, for example, not optimized routes or inefficient transit patterns, for rounds for crew boats on field around the platforms. So yeah, here are some use cases we are working on, and you could work on your side according to what you do. So what all these scoring use cases have in common is that the model's purpose here is to assess a data point and take an action. So it can be a correction or something like that. But here the goal is not to directly provide the final insight to the end user. Because this is the goal of what we call here the modeling use cases. So these use cases are designed to generate directly insights to the final user. For example, we can build models that will automatically suggest the operational activity to report in our interface, so Streamlog. So this is the interface on which vessels report their activities, their daily reports. So we can imagine that the model, by interpreting position data, will suggest activities within the software, so that the user just have to validate it. So it makes it much faster and easier for the captain to report the activities. So here, as you understand, the output of the model is directly displayed to the user. Another use case can be, so you can use regression models, for example, to estimate fuel consumption, which is, I guess, an important topic for a lot of people. So you can use it by using vessel characteristics or activities characteristics. So that's what we call features in data science. Of course, this requires structured data on vessels, on activities, but this is another use case that you can work with. That's what we call regression models, because we output a value here, a consumption model that you can use then in your process. So again, here for these two examples, the goal is not to validate or assess data, but it's more to generate direct insight that drive a decision or improve user experience for the first example. Okay, so I hope that you have a better idea of the different use cases that you can work on by applying data science. So now that you have a better idea, I would like to give you a concrete example of what we are deploying at Opsilog. So this is a use case we are deploying at Opsilog. This model falls into the scoring use case category. And more specifically, it scores the quality of the operational reports sent by the vessels we work with. So basically, this is the first use case on the scoring slide. So as I mentioned earlier, so the data that the vessels report is at the very core of the analytics we provide to our clients. So that's why ensuring its accuracy is a key priority for us. And one of the main piece of information which is reported on a daily basis is what we call the daily report. So it's a sequence of operational activities performed by the vessel, with a start date and end date, a type of activity, and the location, for example. And here, the goal will be to assess the accuracy of the start time and the end time of these different activities in the daily report. So to do this, first we need to verify that the input data is complete. That means checking three things. So first, of course, do we have declared activities, reported activities on the daily report? Because otherwise we can't compute the scores. Makes sense. The second thing is, do we have position data for this vessel? Because if you're dealing with position data, you may know that you don't have data every second, every day. You can lose the signal, for example. So you may not have the data, the position data for a lot of time. So this is an important point to check. The third point is whether we have a defined time zone for the vessel we are working with, because so we are dealing with vessels operating offshore. So most of the time they operate on the same time zone. So we don't deal with vessels with very long transits from Europe to America, for example. So it's important to make sure we have a time zone because they report their activities on local time, and we have position data on GMT 0. So basically, we have to make sure that we can match both. So once all these conditions are met, we can proceed to the next step, which is the pre-processing. So the pre-processing is a linear interpolation. So as I said, you don't have position data every second or every minute. So you have to fill the gaps because you need a continuous time series to feed the model. Otherwise, it won't work. So we do this for three things. So longitude, latitude, and speed. So this step is heavy in terms of computation. That's why you need a strong architecture behind. So I talked about Spark, for example. So this is the kind of technology that you need to process this step, because this is you can't do it, of course, with a simple Excel spreadsheet, for example. But yeah, this is an important step because otherwise you can't feed your this data to the model. So as I said, again, you do it for longitude, latitude, and speed. And just so you know, so each time series has 1,440 points, which is basically 1 point per minute. After the interpolation, you have 1 point per minute. Okay, so once the data is cleaned and pre-processed, it's time to feed it to the model. So I would like to take some time to explain how the model works, because basically that's where all the data science expertise really comes into play. So you can think of it like a computer vision model. So the kind of model that are embarked in cars to detect pedestrians or roads or traffic lights in a 2D image. So you must know that a 2D image is composed of pixels, and each pixel is defined by three values: red, blue, and green, so RGB. And in our case, we work with one-dimensional data, one-dimensional time series instead of 2D image. And each data point, so each minute, so each pixel is defined by three values, so longitude, latitude, and speed, instead of the RGB value. So conceptually, it's a similar approach. You can see the model as a model that will recognize or interpret patterns in the time series, as a model can recognize pedestrians in a 2D image. Here it will recognize some pattern to recognize a transit, for example. So just for those who have more knowledge on data science, so the kind of architecture behind is a convolutional neural network. So this is a very basic architecture for computer vision. So basically what the model will do is labeling each of the 1,440 data points according to one of the three categories that the model outputs. So whether the data point is a transit, is it a standby with movements, or is it another activity? So you may think that the activity are a bit macro and bit yeah, a bit macro. But you have to remind that we only rely on position data. That's why we have only macro categories. But if you had more, if we had more data, more sensor data per equipment in the boat, for HTS or PSV, for example, we could be more precise in the categories of activities. So just I say in the slide that for the first version of the model that we are implementing, we had some issues by splitting the two latter categories, so the standby with movement and the other category. So that's why for the first shot of the model, we decided to merge both categories into a non-transit category. But for later versions of the model, we hope to train the model with a better split per activity. So for example, if you can recognize like a standby at anchorage according to the position, some rounds around the anchor. So that's what we plan to work on. But for the first shot of the model, each data point will be labeled as transit or not transit. And again, you may think that it's a bit trivial to define these categories, but you have to keep in mind that we can do it for hundreds and hundreds of vessels every day, which can't be done if we do it just visually, of course. Okay, so now that we have labeled our data points, we'll try to give more information for the non-transit data points. So what we do is we'll compute the nearest known location according to the position, all the locations that are sent by the client to determine whether the non-transit period is in the port or on the field, so offshore, according to the nearest location. So basically, at the end, each data point will be labeled as transit, in port, and on field. We add 2 rejection codes because, again, here the goal is to suggest the most reliable output. So if we are not sure of the output, for example, if the nearest location is too far, we don't want to output, or we want to say that we are not sure of the output. We prefer to say this instead of saying that the operation is in port and the nearest port is like 20 kilometers, for example. And the other rejection code is if the time between positions updates is too long. So what we do is we'll reject the segment and flag it accordingly, because basically if you have 2 data points and we have 6 hours between 2 data points, many things can happen. So the interpolation that we did at the beginning, we can't use it to interpret the data. Okay, so at the end, we are able for each of the 1,440 data points to label it as transit, on field, or import. There is a mistake, so the no transit is in import, basically. Okay, so now that we've done that, so this is the output of the model here. So we'll just compare it with what is reported by the vessel, and then we'll compare and we will generate a score. So basically here, what we can see is that 50% of the time, there is a match between what is reported and what the model outputs. So which means that 50% of the time there is no match, which is a lot, basically. So here, what we will do is we'll ask, we'll say to the vessel that we detected some inconsistencies. So we'll ask him to correct the report so that we can score it again. And if it's okay, then we will integrate it in our system. Okay, so here is for the example that we are deploying. So actually, this use case highlights one of our key advantage at Opsilog, because as you understand, we have access to two complementary types of data. So on one side, we have, let's say, measured data, so the position data in this example. And on the other hand, we have reported data that we can use them to label our measured data. And to have a labeled data set, this is a major asset when it comes to train machine learning models. That's why for us at Opsilog, it's say easier or more straightforward to train machine learning models and to take advantage of all these data sources. So in this specific case, the model allows us to assess the quality of the reported operational data. So we can request corrections when needed. And most importantly, we can filter and validate the data before we use them to feed other analytics or machine learning models. And basically, that's how we make sure that everything we build on top of that data remains trustworthy and robust to our clients. Okay. So just to wrap up, I would like to give you some key takeaways to keep in mind when deploying a data science project in your organization. So first, as you're dealing with increasing volumes of data every day, so data science can be your best ally to automate process. So automate process and also scale your digital solutions. The fact that you can scale this project very easily is very important, because we will gain a lot of time without using a lot of resources. The second point is, as you can understand, these methods can be applied to a wide variety of use cases. So I gave you some examples. There are other examples, of course. The list is not exhaustive, as I said. And also, the outputs can take many forms. So we talked about scoring use cases and modeling use cases. So basically, the way you use the output of the model can take a lot of forms, and it can be adapted to your processes, internal processes, which is very important. So yeah, this is the second point. And finally, and I think that maybe the most important point, you have to see data science not as a goal in itself. It's a tool to help you drive performance and make better decisions, better business decisions. That's why it's very critical. It's very essential to combine strong technical skills in math and computer science, statistics, with domain expertise. In our case, maritime industry or the offshore industry. So that you can make sure that you are extracting real and actionable value from your data. So basically, that's it. I hope that I gave you some insights, or I give you some information on how you can implement what is data science first, and how you can implement it within your organization. And of course, if you have some questions, I'd be glad to answer.
Well, very good, Samantha. So, yeah, if you'd like to, yeah, we're open to questions now. If anybody has any questions, yeah, if you want to stop screen sharing now, then, yeah, I mean, the thing that comes to me, so this is a very specific example, but shipping companies use a wide range of data. Another one I've been writing a lot about is these energy saving devices that companies are trying lots of different ways to reduce fuel consumption and gathering lots of data, and it gets very, very difficult. But I suppose that's probably another example where this would work. I don't know if that's something you've looked at as ways companies are reducing fuel consumption or that kind of data, or
yeah, indeed, there is a use cases we're working on to compute the fuel consumptions per activity, for example, so that we can give you more insights to the client to help to give. The goal here again, it's not to say you wasted too much fuel, but it's really to make sure that we give the best insights to our clients, so that they can improve their operational behavior. And by using all these data and processing them in the best way and extracting the best value from it, we see a lot of gain, a lot of opportunity actually. So, and which is also very interesting is that you can see it very quickly actually. So first we started with a proof of concept, of course, to make sure that the model is robust. And we can see even on this first part that we can extract a lot of we can gain a lot of things. And so we have a hope that when we'll deploy it on all the vessels and on our production processes, that that all the clients will benefit from it.
Wow, very good. So there's a question come up. Albion Hazy, he's saying you're focusing on positioning on fuel. You're focusing on position and fuel. How about crew management or spare parts management? I mean, I don't know if you've looked into these things or not, but yeah.
So we've not worked on this kind of data yet, but this is when we brainstorm. Yeah, we talked about this kind of data for you like crew data, crew information. So we've not working on them, but I think that this is a kind of example that can be very interesting to work on. But again, the thing which is important is to make sure that even if the quality of your data is not 100% good quality, of course, because it doesn't happen in real life. You never have the best quality. Which is important is to have structured data. And for example, if you have data from the same information in different kinds of Excel spreadsheets, for example, or emails, it will be complicated to process them. Even if today with LLMs it can be easier, but I think that before applying, and this is a prerequisite, and this is important to understand, that before deploying such methodologies, it's important to make sure that you have structured data to feed your models. But then once you have this structured data in databases with data models, you can work on any kind of topic that you may find interesting for your business. And actually, so before I came to Opsilog, a huge work has been made in terms of data structure to make sure that data scientists could work on this data. So in terms of data management and data engineering, there was a huge work before, to make sure we can work with these as data scientists.
Well, there's a bigger picture here that getting good data about how ships are running is incredibly hard. I mean, there's so many things that people just don't know. I mean, one of them is safety management or crew competency. But even this was a relatively simple example. You hear what the ship was doing at any time. I guess knowing what the ship was doing is very hard, and people have been trying for years to solve it. And it's still to be very difficult. But I suppose we're going to need systems like this to clean up the data forever, I suppose, isn't it?
Yeah, you're right, because this you may think that it's very basic, but in terms of all the pre-processing and the modeling needed, it's a huge work. But today, as I said, there are a lot of things, of services that you can work with from providers, for example, in terms of computing resources. It's easier today to use them. The services are very well made to make companies work with these. So it may be basic, but trying to gather all the data and to interpret them in the good way, it's not that straightforward at the end.
Yeah, and it's a kind of a check layer. I guess most data from ships is okay, or like 85% of it is, but a lot of it isn't, and that's what causes the problems. And a system like this can flag things up faster than people can do it themselves, isn't it?
Yeah. Yes. Exactly. Yeah, because today, until now, of course, we had processes to clean the data, to check to make some analysis, to make sure that the data that we receive are accurate. But now we can do it very quickly and with a wider scope, which is very interesting to us.
Oh, just lost your camera there, I think, but yeah.
Sorry.
Yeah, there's a follow-up point from Albion Hazy. I don't know who he is. He may be anonymous, but he's saying gathering proper data is key, but we can't connect everything or ask people to log everything. They already do quite a lot. Calculating and estimating data will be important in the future. But I think whether it's manually provided or not, I'm not sure it makes any difference, because you can have, the example with the GPS, it's all provided automatically, but you still have problems with it, isn't it?
Of course, yeah. That's what we see. Sorry, I have some issue with my camera, but just to
back again.
okay. Indeed. So you can do it for data that are reported manually, but even for data that we get from APIs, for example, we have also some issues, and that's normal. You have to manage this kind of inaccuracies or inconsistencies, I would say. So yeah, you can do this for both.
Yeah. I mean, there's specific. Oh, there's another question here. So, Carl Rasmussen, what do you believe are some of the biggest low-hanging fruits for data science initiatives in a marine setting? I guess is that the example you showed about knowing what the ship was doing, or is it? I mean, I know you're not a shipping guy, so maybe that's but I don't know if it's...
Yeah, but actually, so I discussed a lot with maritime experts to understand what are the key priorities, and so there may be very many interesting topics to work on, like for optimize the routes, for example, which is a very important topic. But yeah, here at Opsilog, we are working with improving the operational efficiency. And this is very critical for us to make sure that we can provide insights for our clients to make sure that the way they work is the most efficient, and they reduce their fuel consumptions as much as they can, because there are many environmental issues today, of course. But we started to work with this data quality topic because this is the basis. I mean, this is really the first step to make sure that you can work on other use cases for routing, for example. The first step is to make sure that the quality of your data is okay. That's why we decided to work on this key priority at the beginning. But yeah, according to what you are doing in your company, I'm sure there are many other priorities and topics you can work on.
Oh, very good. So we've got a question here from one of your customers, Mariusz Lobodzinski. So it's a Polish name, but he says he's with Azul Energy Angola. His LinkedIn says he's working on a drilling rig there. He says, I've been using Opsilog for several months, and there's a comment sent by the vessel. That's an important part of the vessel data evaluation besides other info. But that's the written notes, I guess. I don't know.
Yeah, it appears to me that barcode comments which is sent by vessel. Yes, this is a kind of information that we process also, and today, so we can process more easily this textual data with large language models, the LLM. So this is something also we are working on to make sure that we can work on structured data. So the data very like numbers or just categories, but also a wider range category of data like texts. Today, it's very important to make sure that we can use it and we can automate the processing of this kind of data in our processes. Because, of course, and for this kind of data, before all these large language models emerged, like all these ChatGPT models emerged, it was complicated to process them automatically because we had to read it manually to understand it, and now we can do it more easily. That's also something we are working on at Opsilog, and this is very interesting because here we are at the heart of the innovation in terms of what we can do with data and all the power of what is provided to us in terms of services, as I said.
Yeah, I mean, that's a very different sort of large language model is very different to what you presented here, isn't it? I don't know. They link together at all, do they? Or
yeah, so there is a use case we are working on with LLMs. Basically, we want to, when we analyze the fuel performance, the fuel efficiency performance of our vessel, we can spot some rooms for improvement in terms of operational behavior. So when we want to communicate what they can improve, today we do it for the top, for the vessels that waste a lot, the most of fuel, but we can imagine a system where the model will interpret the data for all the vessels and then sends notifications or messages for all the vessels, which can be very powerful because we analyze that if we send very personalized messages to the vessel, the message is easier for the user to understand instead of just an Excel spreadsheet or something like that. So yeah, this is another thing we are working on, and which is another completely different use case from what we've talked about.
Yeah, I mean, if you're working with Apache Spark, that's data as in numbers, isn't it? I suppose it's
Yeah,
not
exactly.
text in there. Yeah, that's very interesting. Wow. So I guess this is going to grow and grow. I suppose if the more data ships make, the more they're going to be looking at things like this to try and filter out what's good and what's not in it, I suppose, isn't it?
Exactly. So I think that it's you can't escape from data science. I mean, if you have data and you process data, or at least you have data in your company, one day or another you will have to deal with these kinds of technologies, which is evolving very quickly also. So that happened for many industries. Now I'm sure that the maritime and offshore industry is no exception at all. That's why it's important to make sure that we embark these technologies in these industries.
Yeah. What's the best way for shipping companies to engage with this? I mean, if you imagine a company with, say, 10 ships, they've probably got a lot of data. Should they have somebody on their staff who's got a maths degree to try and sort through it and find patterns in it, or was it?
Yeah, as I said, so the starter pack, I would say, is make sure that the data that you collect are structured. And if it's not the case, you have to do this at the very beginning. And then, yeah, you need people who have some skills in analyzing data, of course, but also people who can understand the business environment they are working on. And this is very, very important because, again, you can be the best in math and create the best model ever. If it doesn't respond to a business need, then it becomes useless. So it's very important to have this hybrid, profile of person who can understand business needs and also analyzing, dealing with data, which require some skills in math and statistics, computer science.
I guess there aren't many such people around who know both data science and shipping, I suppose, isn't it? But I guess
there will be more and more, I hope.
Yeah. I guess most graduates are doing some data science. Yeah, we've got another question from Carl Rasmussen. He's from Ulstein, I think. So do you have some kinds of standards to evaluate if the data is good enough?
Yes, of course. And so this is a very interesting question because these standards are directly related to what with the collaboration with the business, because basically this is the business that will say, okay, so this is good enough. This is not good enough, and that's with them we managed to define some thresholds that we say, okay, on this case the data is not okay, on this case is okay. And what we did is that we that we updated these thresholds according to, okay, so we put the threshold a bit low, for example, at the beginning, to make sure that we extract only the worst cases. And when we managed to improve the data quality, we increased the threshold. but always in a collaboration with the different teams that have the knowledge to say, okay, from a business point of view, this is okay, this is not okay. So of course, this is not only a business decision; it's in collaboration with the teams, but it's a global decisions made by all the teams.
Yeah, I'm just looking at, Carl, I'm looking at your LinkedIn page. I can see you're a data scientist at Ulstein in Oslo, so doing this similar kind of thing with shipbuilding. I suppose it's linking data science with the real world is tough, I suppose. This is exactly what you're grappling with. There's no perfection, but there's also some things that we can't work with and some things we can work with, isn't it? And yeah, I suppose this is where we're going, isn't it? And yeah, if you can get into a ship inspection data, that's an enormously complicated world we're also writing a lot about. That's don't know if anybody's used data science with that, but that seems like you can see how well a ship is being operated. Well, that's fantastic. Well, I think we can bring the webinar to an end there. There's no more questions. I don't know if you want to leave any further words to leave people with, or how.
But again, thank you, Carl, for your invitation. I hope that I give you some ideas on how you can implement these technologies. Again, I think that this is very important to understand, even on a high level, of the power of implementing such technologies. It's the cost is not that hard. You need some prerequisites. We talked about them, but it's very. I think the benefit that you can take from it are huge. We can see it very quickly. So that's also an important thing, that what you can gain from it, you can see it very quickly. So you don't have you don't have to wait for years and years to have the benefit from the investment. So yeah, I hope I give you some ideas, and you have some ideas of use cases that you could implement within your teams.
Yeah, well, thanks for opening the door to the wonderful world of data science and shipping. So that's it from us. I shall thank you. I shall pass back to Farah for the closing words. Cheers.
Thank you to our guest speaker, Samanth Chinta, and our sponsors, Opsilog, and to our audience. Join us next month for our vessel performance info webinar with Tokwa, which you can book online. If you missed our Q&A session, don't worry, we'll be sending you contact details soon, along with a link to a recording of this webinar on our YouTube channel, which you can subscribe for. Also, please feel free to fill in our survey, which will be appearing on your screen shortly. See you soon.
Bye-bye.
Thank you.